Hi, today I'm just solving problems from old contests that I didn't finish. The first one I'm doing is this problem called playoff fixing, which is from educational Codeforces round 149. And I thought I had some ideas for this. Let's see, I will explain the question. Let's see how this goes. So the question is, yeah. There's a tournament that 2 to the K teams play in teams, and each team has a number to begin with, right? The team 1, team 2, and so on up to team 2 to the K. And so that number determines their strength. So team 1 is stronger than 2, stronger than 3, and so on. So let's, for example, let's say K is equal to 3. So you have team 1, 2, 3, 4, 5, 6, 7, 8. And if 4 plays 8, 4 will win. If 6 plays 8, 6 will win. If 2 plays 4, 2 will win. So this order determines their strength. And then they also have a seeding. Okay. So seeding is something that determines the order in which they will play each other. So let's say if their seeding is, so this is the seeding, is 3, 4, 1, 7, 2, 6, 5, 4. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if this is their seeding, the team with seed 1 will play a team with seed 2, which means 3 plays 5. So let's see. The way it works is seed 1 plays seed 2, seed 3 plays seed 4, seed 5 plays seed 6, and seed 7 plays seed 8. Okay. So seed 1 plays 2. So seed 1 here is 3 and seed 2 is 5. So team 3 plays team 5. And then team 1 plays team 2. Team 5 plays team seed 5, plays seed 6. Seed 5 is 7, plays seed 6. Wait. And then seed 7, 4 plays 8. Okay. 4 plays 8. So obviously when these two guys play, 3 will win. When these two guys play, 1 will win. When these two play, 6 wins. And when these two play, 4 wins. And when these two play, 1 wins. These two play 4 wins. And then between these two, 1 wins. Now, based on this, we assign the ranks, right? This guy gets first place because they finish first. 4 gets second place. This guy gets second place. Okay. Then these guys both get third place. And then since we assigned 2 guys to get third place, so we skip a number. And this guy gets 4th place. This guy gets 4th place. 2 gets 4th place. And 5 gets 4th place. So finally, we have team 1 getting first place. Team 4 getting second place. Team 3 and 6 getting third place. And 5 to 7 and 8 getting 4th place. 7 and 8 getting 4th place. Okay. So this guy gets first place, second place, third place, fourth place. Now, the question says we don't want this. We want to rig this a bit such that the stronger guys, I mean, the guys who in the initial, like the stronger guys get the higher position and the weaker guys get the lower position, right? We want to rig this such that 1 gets first place, 2 gets second place, 3 and 4 get third place, and 5, 6, 7, 8 get fourth place. And for that, we have to change the seeding. So the question asks, how many possible seedings are there such that we get the final positions that we want? And not only that, if given some seeds being fixed, like suppose we say fourth player is definitely going to be seeded at 6, right? Given those some seeds being fixed, how many seedings remain such that, potential seedings remain such that in the end, the rankings will be according to the original strengths. Okay. So in this case, this is an example where it clearly was not. This seeding that we had here is not one of the seedings they're looking for. Okay. So how do we solve this? Maybe we can ask the simpler question of, and this is, I thought about this a bit in contest, but that was a long time ago, so I'm just going to explain everything. One of the things we can do to simplify this is assume that they don't give us any seeding. We just need to count all possible seedings, right? How would we do that? So for the guy with of position 1, there are n ways to choose their seed. And for the guy with position 2, you just don't want him to be in the same bracket as 1. So they can just be in the other half. That's all. As long as they're in the other half, they'll reach the final, which is what they want. So there's n by 2 ways to do this guy. Right? So maybe I'll do this. This is where 1 is. This is the bracket where 1 is. This is the bracket where 2 is. Now 3 and 4. 3 can either be like, in the bracket where 1 is, but not in 1's quarter, right? Or in the bracket where 2 is, but not in 2's quarter. So 3 can be anywhere here. And if 3 picks a place, 4 has to pick the other place. So there's n by 2 like positions for 3 into where n is equal to 2 to the k, by the way. N by 4 positions for 4, right? This is 3 and 4. And then for 5, once again, 5 can be here. Like 5 can be like, as long as it's not in 1's 8th or 3's 8th, that's fine. Or 2's 8th or 4's 8th, right? So there's again half position for 5. And 6 can pick 3/4 of what's left. 7 can pick half of what's left. And 8 can pick a quarter of what's left, right? So these would be the number of ways. So for example, if n was 4, there would be 4 ways to pick 1, into 2 ways to pick 2, into 2 ways to pick 3, and 1 way to pick 4. So that gives us 16 seedings, right? So maybe just like we can draw all the potential ones. You can start with 1. And 2 could be either here or here. So you could have 1 here, 2 here, And 3 could be here or here. It could be 3, 4, or 1, 2, 4, 3. Right? Or 1, 2 could be here. 3, 4, or 1, 2, 4, 3. Right? And then again, I guess 1 could be here, 2 could be here. So you could have 3, 4, 1, 2, 3. 1 here and 2 here, so 3, 4. 4, 1, 3. Then you could have 2 here and 1 here. 3, 4, 3. 1 here, 2 here, 3, 4. 2, 4, 1, 3. 1 here, 2 here, 3, 3, 4. 2 here, 1 here, 4, 3. Oh, sorry. I need a 2 here, a 1 here, 3, 4, and a 2 here, 1 here, 4. That's interesting. 16 out of the, actually the potential seedings out of 4 factorial seedings, right? 24. So 16 out of 24 would have been allowed in this case, but otherwise it's probably much less than the total. So all of these are valid seedings, and if we take any one of them, we get the right ranks, right? 2 plays 4, 1 plays 3, 2 wins, 1 wins, 1 wins. So 1 gets first rank, 2 gets second rank, 3 and 4 get third rank, as they should. So this is fine. This is easy enough to do in O of n, right? 2 to the k is, I think, 19. So 2 to the 19. Oh, it's not too big. It's within int. Okay. So now the question, I guess, is what if they give you a seeding, and an example is, I guess, 1, 2, 3, 4. So this is an example. Oh no, that's, they give you everything. Maybe where they give you. Okay, maybe they could give you 1, 2. Okay. Yeah, sometimes my journal misbehaves, but it's okay. It's rare enough that I don't have to do anything. Okay. So for example, so that is, so we know that the case where they don't fix any seeds, we know how to do compute number of seedings. That's very easy. Now, what if they fix something? So, yeah. let's say 1, 2, something, something. Okay. Here clearly 1 and 2 are in, the same bracket, and we don't like that. So here there's clearly 0 ways of doing 3 and 4 to do this. But how do we? So there's two things, right? Either the seeding they give is not compatible at all, in which case there are 0 ways to continue, or the seeding they give is like a valid thing, in which case it's like fixing the number for that element, and we can just go ahead and multiply all the rest of the elements like how we did here. So for instance, if 1 was fixed, right, we would just multiply n by 2 into n by 2 into n by 4, all the ways, given 1 was fixed, all the ways to do this without the n. And if 1 and 2 were fixed, we would just multiply n by 2 and n by 4. Or if, oh, it's not that easy. Because say if 3 was fixed, what does that mean? I can't just multiply everything except this, right? Yeah. Okay, so that's something we need to think about. Okay, I guess let's solve the first question, the first problem first. How do we figure out whether the given seeding is compatible? I mean, like this given the part of the seeding they give us can still be has valid completions. Maybe I should say this. This part of the seeding they give us has valid completions. Okay. The way the seeding is given to us is, yeah, team AI has seed. Okay, that's fine. I was thinking of this. If Yeah, what we need to check is that so let's say these are the teams. 1 and 2 aren't in the same half, right? Halves 3 and 4 are in. Okay, with team 3, it can not be in the same quarter as 1 and 2. Yeah, this checking part is a bit idle. Or is there a way to restate this? Okay, what comes to mind? Thought I had this down. Yeah, okay. I think I will look at the solution. Oh, okay. Let's say 5 minutes before looking at solution. Okay, what are the questions I am not asking that I should ask? When exactly do we say there's a conflict? What is the definition of that? I say there's a conflict if two guys end up competing before they have to. So for instance, 1 and 2 should only be competing in the finals. Okay, 1 and 2 should be competing in the finals. Five, 6, 7, 8 should be competing till the quarters. So a team getting eliminated. No, I guess I'm stuck. Right. Okay. What does this mean? Quality and understanding editorial. Hmm. Oh, I see. Okay, so I think I understand the solution. Maybe I could. Yeah, this seems like a good example. Okay, so I just went over it. I will draw this again and explain. I don't know if I can make this like a slightly better example. Okay, let's try this. So this C, let's say this is a particular arrangement we have. Seed is 1, 2, 3, 4, 6, 7, 8. And player is 3, 5, 1, minus 1, minus 1, minus 1. Or does not hit. Oh, I have 5 twice, which is weird. Maybe 6 minus 1. Six minus 1. So the key idea is as follows. In the first round, we know that every guy, if we take the pairs, like seeds 1, 2, seeds 3, 4, 5, 6, and 7, 8, we know in every pair there has to be one guy from the first half, like 1 to 4 in this case, and one guy from the second half, because all the second half guys we know get eliminated in the first round. And similarly, when you go to the next round, there has to be, in each pair, there has to be someone from the first quarter and someone from the second quarter. Otherwise, it's invalid, right? Again, when you go to the next round, someone from the first eighth and someone from the second eighth in each pair. So I guess that was one important observation. And that tells us how to eliminate guys. But it's the algorithm they have to solve it is quite neat. So say the seeds and players, this is the question given to you. What you can do is look at the first pair. You have 3 and 5, so it's fixed. And there's one guy from the first half, one guy from the second half, so you're good. And 3 gets promoted to the next round. Okay, now look at this. You have 1 and minus 1. Here you have, there's some guy from the first half, but they have to be matched with some guy from the second half. But the first half guy will get promoted. We know this. But we need to figure out how many ways are there to fill in this minus 1, which we'll do in the end. Minus 1, we know that one of these, the winner, which is minus 1, some unknown guy, will get promoted up. And we need to figure out a way how to fill this. And we also know that since however we fill this, we can swap the way we fill it. So we have to multiply by 2. And 6 and minus 1, we know minus 1 gets promoted. And yeah, okay. Now, in the first round, how many ways are there? Can we fix any of the minus 1s? Okay, which guys can we, what do we know? We know that 5 from the second half and I guess 6 from the second half are already there. So 7 and 8 from the second half are left. So if you look, so we can ask which guys have a loser that needs to be filled. A loser meaning a guy from the second half. So this pair has a loser that needs to be filled. This pair has a loser. We don't know which it is, but there's definitely a loser. This pair doesn't. So there's 2 pairs with a potential loser times number of pairs where both guys are not fixed, because we'll be able to swap them, so you get another 2. So we have 2 factorial, right, for the losers times 2 for swapping these 2. If we had another minus 1, then for example, if we had a minus 1 here, then it would have been 1, 2, 3 losers, so 3 factorial ways, times 2 ways of swapping this, times 2 ways of swapping this, into 2 into 2. That's what it would have been. But that's not the case. Okay. Now we are here. 3 and 1. One guy from the first quarter, one guy from the second quarter, so valid, and 1 gets promoted. Minus 1 and minus 1, so minus 1 gets promoted. Here there's 1 loser, right? So 1 factorial times 2 ways of swapping them, so 2. Then again here, we know one gets promoted, and here there is one loser times nothing. So the total answer is for this 2 factorial into 2 into 1 factorial into 2 into 1 factorial, right? 4 2s are 8. 8 potential ways, and maybe we can see. So 1, 3, 1, 3, 5, and 6 are filled. We are left to fill 2, 4, 7, and 8, right? So if we look at here, I guess we could, there's two ways to pick this. We could have filled this with 7 or 8, and that fixes this, but there's one way to fill this with 2 or 4 times the swap, and that ends up fixing this, so into 2, so that checks out. So I guess that's what the algorithm is. I will hopefully code it up soon. So yeah, that's it for today. Thank you.